Now today we are going to have a look at the product rule in differentiation. Let's say if there are two terms that have been multiplied, u and v, then according to the product rule, the u we keep as it is, we differentiate the second, and then we keep the first, which is v, and then we differentiate the first one. Now this is the formula for the product rule. Just to give you an example, let's say we got u dot v. Why we choose u dot v, even though they both look very similar? In all of the books you are going to see uv. Now if I want to differentiate that one, d over dx, the u and v can be any function. The formula states you can keep the u here and you can differentiate the v. It's no specific order. Plus is always plus in the middle. You can keep the v and you can differentiate the u. This is the product rule. Let's say we have a question where the question is y equal x plus 1 to the power 5 multiply by 2x cube. Now here I have to choose the u and the v. So according to, I have to apply the product rule because I cannot expand that one. It's very difficult to expand this one. So I'm just going to go for u. So now the u, I'm just going to take u equals x plus 1 to the power 5. And then v equals 2x cube. I need to differentiate that one. And when I differentiate this one, du over dx, according to the law, the 5 comes out, reduce the power by 1, and then differentiate this thing. If I differentiate x plus 1, the answer is just a 1. So I don't need to write here 1. In your assignments, you need to do all the steps. I am skipping the steps, but in the previous videos, I have done all the steps. Now here, I'm just going to do dv over dx. The 2 is already out. The 3 comes out. Reduce the power by 1. So, which will give you 6x squared. So now I got u, I got the du, I got the v, I got the dv over dx. So I got all these. Now according to the product rule, I am going to put that one in the product rule. So the product rule was, if I got d over dx of u dot v, it's u and then dv over dx plus v du over dx, and now we'll just input the values here. The value for the u from the previous one is x plus 1 to the power 5. So instead of that one, x plus 1 power 5. The dv over dx from here, I got 6x squared. So I put 6x squared plus v. V was 2x cubed, so I write 2x cubed. Du over dx was 5x plus 1 to the power 4. Now I can simplify that one. I can factorize and I can simplify that one. If you have a look at that one, this is a 6, this is a 2, this is a x cubed. So I can straight away, and obviously there is a 5 there, so I don't want to touch the 5 for a while. If I rewrite that one, that becomes a 6x squared, and that becomes a x plus 1 to the power 5. I just rewrite. I just move that one here and there. 2 times 5 is a 10, so that becomes a 10x cubed, and then I got x plus 1 to the power 4. If I want to simplify it, I can take 2x squared common. So I'm dividing this thing by 2x squared, all these things. And also I can take x plus 1 to the power 4 common as well. So I'm dividing this whole thing by this bit. So I got the answer as 3x plus 1. Plus, here when I divide this whole thing by this, I got the answer as 5x. X plus 4 is gone, so outside. So this is what I will get. I can further simplify the one in the square bracket. That one I can leave it as it is. The one in the square bracket I can further simplify. So let's have a look. So let's have a look at the simplifications of that one. So if I want to further simplify it, the one that's at the bottom, I can get 2x squared as it is, x plus 1 to the power 4 as it is. That becomes a 3 times x is 3x, plus a 3 plus a 5x. Now if I further simplify that one, that becomes a 2x squared, x plus 1 to the power 4, and here I got the 8x plus 3 because 3x plus 5x is 8x, and that is the answer. This is the solution. Now, if you notice here, there are some questions which involve the tan, sine, and cos, and e to the power minus x. Now, how do we differentiate e to the power minus x, e to the x, and so on? In this question, you can take does not matter which one you take u and v. Let's say is this one, I'm taking u as x cubed, and I'm taking v as 4 minus x to the power half. When I differentiate this one, du over dx, that becomes the 3x squared. Obviously you need to write full step, differentiate with respect to x and so on. When you differentiate this one, dv over dx, the half comes out, reduce the power by 1, so half minus 1. Yeah, and then you need to differentiate this box. But when you differentiate this box, differential of the 4 is 0. Differential of this minus x is minus 1. So that will be a minus 1 will appear here. And then if I simplify that one, that's a dv over dx. That will be equal minus the minus, I can put that one here. So minus half. And then I go 4 minus x to the power minus half. Now that's a 2. Now I'm just going to use okay. Now we got this bit. Now I'm going to use the product rule. To use the product rule, I got u and then dv over dx plus v du over dx, and now I need to put the values. Now the value for the u is x cubed, so the x cubed is here. The value for that one is minus half 4 minus
where the minus half?
Minus half? Yeah. Here, this is minus half.
Yeah, where
there was a half here, which was the power out,
yeah.
And there was a minus 1 there as well, because when I differentiate 4 minus x, the answer is minus 1. Plus, now the v value is here. This is the value v, 4 minus x. and the du over dx is 3x squared. Now according to the law of indices, well, I can write it as this thing, whole thing I'm multiplying, so I can just write it minus x cubed, because that and that I can multiply. This 4 minus x to the power of minus half, this is minus half. So I can actually, the 2 is already there. 4 minus x, I can take it at the bottom, you know, and I can call it positive half. Because when you move from the top to bottom, the power sign change. Plus that is 4 minus x, and this is a half. And then 3x squared, done. Now what we need to do is, we need to further simplify it. To further simplify it, we need to use the denominator, we need to make the denominator same. So here, in this denominator, on this side, what's missing? 2 is missing, so I have to put 2 here. I cannot just put a 2 here randomly, because I've changed the value, which means I have to put the 2 on the top as well. Now it's balanced. I want to make the same denominator here. Now here I got 4 minus x to the power positive half. So I have to put that one here as well. 4 minus x to the half. But I can't do that one, so I have to put here as well. Now this is to make the denominator same. Now once the denominator is same, I can draw a big line, this positive from here, and I got 2 bracket 4 minus x. Now here I got minus x cubed from here, and here I need to copy all that bit. Now if you have a look at that one, this is 4 minus x to the half, and this is also 4 minus x to the half. According to the rule, if I got this bit and this bit, they both are exactly same base. This is called the base is same, power is half. I can add the power, so I can write it down. I can write them down as 4 minus x to the power half plus half, so that will become just a 1, and the 3x squared as it is. That 2 at the bottom, that 2, yeah, that 2 can multiply with a 3, and you can get an answer 6. Yeah, so we do that in next step. Yeah, thank you. Now we need to rewrite this one. So now we need to rewrite this one. Let me just clear the screen. So now in the previous slide, we got this as an answer, the last step. So that will be a minus x cubed plus 4 minus x. Yeah, I can write 4 minus x. I don't have to put 1 here. I can just get rid of that 1. And then dot 6x squared divided by 2 bracket 4 minus x to the half. Now this is a minus x cubed. I need to multiply this with that. So 4 times 6x is 24x squared, and minus x times 6x is minus 6x cubed, and the denominator stays as it is. I just copy the denominator. Now here this minus 6x and this is minus x, so that becomes a minus 7x cubed, and on here I got 24x squared. So 24x squared minus 7x cubed divided by 2 bracket 4 minus x. I cannot multiply the 2 inside because there is a power here. So this bit is the solution.